Okay, so in this first example, I will be working with images of comet number 276. As you can see here, there are 30 exposures. They are each 60 seconds in duration. Now, keep in mind that the pre-processing routines have already been completed. This is the calibration, plate solving, and alignment routines. So if you want to learn a little bit more about those, feel free to consult the user guide, which goes into those steps in more detail. So having completed pre-processing, I can go ahead and navigate to Action, View Images. And as you can see here, this is the comet that we wish to measure. So at this point, we can go ahead and go to Photometry, Comet Photometry, and this presents a new window. And as you can see here, there are several parameters to be populated, the first two of which concern the star image and the comet image. So the star image can be either a single exposure or a stack of exposures. So what we want to do there is to construct a stack of exposures using all the images in the data set. So I first want to double check the settings for the stacking operation. So we can choose from average, maximum, median, and so forth. I like to use median stack. And because this is the star image, I want to make sure that there are no motion offsets applied. Again, we want, in this case, the stars to be nice pinpoint objects. So I choose 0 motion. And with that, I can now proceed to do select all images, and it will create the stacked image here as you see in this view. So this is the star image. And from that, I can choose apply from image viewer. Next up, we have the comet image. And a couple ways to do this, but what I like to do is click on the first image in the data set and zoom in and then double click to center the object and then right click and create marker 1. So this defines the first position of the comet. And then I'll scroll down to the last image and then double click to center once more and then right click and choose create marker number 2. So these two markers define the motion of the object, and then I can create the stack according to this motion. So again, I want to double check my settings here. In this case, this is tracked motion. And from that, I can choose right click, create stack from markers. So this is the stack according to the motion of the object. And as you can see here, I can now proceed to apply that from the image viewer. So we have the star image and the comet image. Those are both set. And the origin follows here soon. I simply double click to center it. It's already centered, and I choose apply from image viewer. So we now have the origin specified. And one way to double check that is if I move around the image and I click go to, it should recenter it, and it does. So that has been specified properly. Now if you want to, you can also invoke the star removal routine. So if I choose the default parameters 7 and 3, we can see what that looks like. So these parameters, the first one is the ignore radius, which simply specifies the starting radius at which the routine takes place, and the coefficient determines how aggressive the routine is. A larger coefficient makes it less aggressive, whereas a smaller coefficient value makes it more aggressive. So you can adjust these parameters as you want. Now you can see here that it may be a little bit too aggressive with this default setting for this example, as it appears to have removed a little bit of the comet signal. So one way to mitigate that is to increase the ignore radius. So I can do that here. So I revert the changes and then apply once more, and you can see what effect that looks like. So with that in mind, we have now applied star removal, and now we want to finish populating these parameters. So this is the comet name, comet Earth distance, comet sun distance, and so forth. And one way to do that pretty easily is to go to Settings, Overlay, and from this window that appears, I can choose Apply Object. And a couple ways to do this. If you know the number of the object, you can input that, or the name. So the number of it is 276, and so I can choose Search, and you'll notice two results are returned, the first of which is minor planet number 276, and the other is the actual comet 276P. This is a periodic comet. So I want the second result here. I click OK, and we give it a moment here to finish the computation, and you'll notice that when it has done that, these parameters have now been filled in. So That leaves 2 steps remaining before we get to the actual generation of the measurements. So these 2 steps are to modify aperture settings and to select comparison stars. So I first like to select comparison stars just to know what kind of aperture I may want to use. So the comp stars in the lower left corner, those are typically the brighter ones. So for example, if I click on the star image, you can see it here. This is a very bright star. You probably would not want that for a comp star because it is probably saturated. One way to check is to right click and choose View Object Profile. And you'll notice indeed this is a saturated star due to this flat profile here with these elevated ADU counts. So I would not want that to be a comp star. Now if I click on another data point here, you can see what that profile looks like. So I might choose that as a comp star, but either way, you have options here what you want for comp stars. So with that in mind, I'm going to click on one and then choose this setting here, Modify Aperture Settings. Another way to access that is to simply go to Photometry, Modify Aperture Settings here. So now these are the aperture settings that we would want to have for the comp stars. So keep that in mind. A couple ways to do this. One, you can leave the default setting here, which has where the comp stars will use the same aperture as target, and that is perfectly safe to use with Comet Photometry because it will actually override the target aperture with its own setting. In other words, it does not use the target setting you have here. So whatever aperture setting that you've specified here will essentially take place for the comp stars. Now, if you want to, just to be more explicit about it, you can uncheck this box, but just keep in mind that you will have to click on the comp star button to specify the aperture specifically for comparison stars. So either way works. So in this case here, I am perfectly fine with this aperture setting. So I can click close and I can proceed to finish adding comp stars to the list here. I typically do between 5 and 7 comp stars. Now you'll notice that another way to do it, if I wanted to, is I could simply double click on a star in the image and then right click and choose Add to Active Comp Stars. So that is one way to do it as well. So anyway, I'm going to finish adding comp stars again until I have about 5 or 7 of them. I can also choose Graph Generate Data, and that shows what the computed magnitude is over time. So that's one way to validate if they are variable stars or not. So that concludes the setting for the aperture as well as the comp star selection. So at this point we are now ready to generate measurements. So I click on Generate Measurements and you can see that 2 windows have now appeared. One is the Comet Graph window and the other is the Comet Report. So the Comet Graph window, if I want to, I can click on the data point and it will indicate the magnitude at a particular radius. The Comet Report window shows the different magnitude at different apertures. So we have 10 by 10, 20 by 20, up to 60 by 60. So lots of useful information here in this report. But this is a bit of a fainter comet, so it does not have quite as many data points. In this next example, I will show a brighter comet and what that looks like. Okay, so this is the second example. In this case, I already have stacked exposures on the comet and the stars. So you can see I have just 2 images loaded here. So I go to Action, View Images, and if I zoom out a bit, you can see that this first image is the comet image because the stars have that trailing or streak profile to them. And the second image is the star image because the stars are pinpoint. So as before, we can go to Photometry, Comet Photometry, and I will go ahead and choose the star image. This is the star image here, and I go to the comet image and click Apply from Image Viewer. So we've now specified both the star and comet image, and now I want to set the origin. So I adjust the contrast to see it better here, and double click on it to center it, and choose Apply from Image Viewer. So we've now specified these first 3 parameters, and as before, if we want to, we could invoke a star removal routine. So if I adjust the contrast a bit more, we can see what we're looking at here. So if I choose again the default parameters, we can see what that looks like. So it looks like it's a little bit too aggressive because it has subtracted a little bit of the comet signal. So if I increase the coefficient value, we can see what that looks like. So that might be a desired setting. So again, feel free to adjust these parameters to your liking. Now, as before, we want to finish populating these parameters. So I go to Settings, Overlay, and choose Apply Object. And this is Comet 13P. So I choose the second results here, Comet 13P. Click OK and give it a moment to finish populating these parameters. So it has done that now. So we now have star image, the comet image, the origin has been set, and we've done star removal to our liking, and we've also populated these parameters. So as before, the final two steps are to do the comparison stars and the aperture settings. So I click on Select Comparison Stars, and you can see this trend line here. Now you might notice this sort of behavior. The reason for that is that these stars at these magnitudes are simply too faint. So if we want to, we can put a limit on the max magnitude. So I click on this checkbox here. Again, a way to see that is if I go to the star image, click View, you can see that there is no star here. There is one right next to it, but it is not actually the star in the catalog. You can see that there are two stars identified from the catalog here, and this one is simply too faint. So it does not have any actual useful image data to work with. And that's the case with these other data points here. So typically if you care about that, it's not really necessary to do it, but if you want to, you can put a limit on the maximum magnitude. So I check the box here, click refresh, and you can see that cleans up the trend line. Okay, so again, we want to choose comparison stars, so I can click on one here, and I also want to look at what aperture setting I may want to use. So I click on Modify Aperture Settings, and again, this is a reasonable aperture. I may want to make it slightly more enclosed, but either way, this is acceptable. So I can choose that aperture setting, click Close, and I again just might want to add in 5 to 7 comp stars. So once I've done that, then I can say that we've now identified our comparison stars, we have set the aperture settings, and we are now ready to generate measurements. Now you can see here, this has a lot more data points because it is a brighter comet. So I can go to that origin here, you can see what that looks like. So again, two windows, the Comet Graph window and the Comet Report window. And again, as before, I can click on a data point and see what the computed magnitude is at that radius. So that's about it for this tutorial. I hope you found it informative. So thank you for watching, and see you next time.